All right, Michael. Since we didn't really get to do the webinar, I figured I'd give you guys a short demonstration that maybe you can have a look at, share amongst yourselves in preparation. So, um, the AVE shortcut, I just moves up to my desktop and it will open up this fine little cross window. Alright, you guys are primarily dealing with LAS files. So, first step, we'll make ourselves a little trackline output file so that we can build our PFM. Alright, where shall we put it? So that'll be our output file. That's fine. Take our LAS file. And run it. Alright, so it's created this LAS example.are file, which is a simple bounding box based upon what points it found in the LAS file. So we're going to use this to build our PFM grid. If we wanted to, we can use the area check software and say, well, where on earth is my little grid? Looks like it's this LAS data is topo data up here in England somewhere. So then if we were to build our PFM file so we can view and edit our data, this will be our file, this will be our PFM file, which is basically just a handle. It's going to point itself down into this directory where all of the subfiles are going to be created, the bin and the index and everything else. If you have any questions about any of these options, you can click on the Help menu, and then click on it, and there it is. The PFM is basically a giant grid. So it's going to dump all the points into we're going to say we're going to make a 2-meter grid. So each grid cell is going to be 2 meters by 2 meters throughout the entire area. And any points that go into that area will go to form that grid value. So you'll have a minimum value for the grid, which is the Shoals point, the average value for the grid, and then the deepest value of that grid. And then when we open up in the viewer, we see all the points in those grids. So let's grab our area file. That way it knows how big a grid it's going to make. And we can queue a whole bunch of these up if we were going to do them all at the same time, running through the same files. I know this is going to be LAS files. You can add additional options that we could sort by, intensity, classification, etc. for the LAS. I'm just going to put classification in there. Again, the help menu is pretty extensive for everything. I would highly encourage you to utilize that. And there's our LAS file. All right. And now we're going to load to build our PFM. And this should be relatively quick. All right, finished. Now we're going to bring up our viewer, PFM view. There's the PFM file that we just created. All right, so over here on the left, we have our overview. I know this is a small area. I think it's like 800 meters or something to that effect, so I can do this. Otherwise, you would normally take like a small chunk of it if it was like kilometers by kilometers area, but I know this one actually happens to be pretty small. So there's our gridded surface of our last file that we can bring up. Unfortunately, there's no imagery or anything to go along with it, but from here, I can bring it up into our 3D viewer. So let's load up this little area. And now by holding down the control key, I can click and drag to rotate the surface around, looking for spots that I might want to edit. All right, you see the information over here as I'm rolling around on the point cloud. This is Z value, so looks like it's some building. All right, so I'm willing to bet that was an issue where something was reflected off the laser shot, which is why it's showing much lower. So if I wanted to, let's say I decided for whatever reason that I did not want these points, I could box them up. And of course the ubiquitous undo key. Or if I wanted to do it by a polygon. Or if I wanted to say everything outside the polygon. Let's say I only wanted to keep this. And it deletes everything else. So you can keeps getting stuck. All right. So using the scroll mouse on the scroll wheel on the mouse, I can slice through the data. You see it moving back and forth. If I wanted to try to investigate, find the points that I was particularly after removing. You see how it's going back and forth through it, and everything else becomes transparent. So now anything I took out, if I was deleting major points, would only be what's currently visible in this view. Like anything that's transparent, I wouldn't accidentally delete. Hit the escape key, brings everything back so you can see it and continue your data manipulations. All right, there is also a LiDAR classification mode now. So if you need to change a section, I want to change how the classification tags, we can do that here. What would I like to, it's all classified as ground. If I wanted to change it to road surface, whatever, this is where I can do that as well. So I can save or exit without saving. All right, so how big is this entire area? You see there in the bottom right-hand corner, it's 1,075 meters from that point to where I've drug it. So roughly a square kilometer is what we're looking at here. The color coding is red will always be the shallowest, and purple will be this magenta will always be the deepest. And to dismiss that box, I just center clicked if I didn't want to make a selection, or right click, center click. There we go. All right. There are also the various filter options if we had like a bunch of points that we wanted to have gone all at once. Now, let's see, what do we have here? So last classification, there's a classification tag. For those points. So that was right here. Let's say we wanted to get rid of those. We set our standard deviation as to what we wanted or what we did not want. So we could just do deep filter only, so it only delete those things that were 2.5 standard deviations below the surface, or we could, set it to filter everything. Be very, very careful with using the filters. Typically, I'll go through an area when I'm cleaning it and look for all the flyers and make certain there's nothing that I really want to keep in the editing mode. Decide, yes, I'm really interested. I'll clear through the entire area and say, yes, I don't want to keep any of that. And then I'll come in with the filter and blast through it and have it filter at 2.5 standard deviations. Or maybe if I really want it to be a clean surface, I'll say 2 standard deviations. I would urge you against filtering and then refiltering the same area, because you're killing off more data. So only filter one time is my advice. So I've gone through the entire area, decided yes, that's fine. So apparently that's more than, it's within 2.5 standard deviations, so nothing got pulled. So let's delete some data. And you see it's gone out of the surface as well. I tend to take the auto redraw after edit off so that I can see where I've been. So say I'd gone through and I looked at that area. It's like, okay, well, I'm not going to edit anything there. Now the box stays. Gone through this area. I want to look at this point. So I decide, well, you know what? I don't want to see that one. We'll save that. It shows the box. It's not been redrawn. I can kind of see where I've been and what I've already investigated. Like, let's say I don't. For whatever reason, I've decided I'm smoking those last points. I'm not going to deal with them. And as I've gone through, and I was like, all right, now I want to redraw. Okay, and now they're gone. A tool that a lot of folks like to use is the highest point, lowest point, and the point with the highest standard deviation, which is the triangle. So the circle is going to be your highest, the square is going to be your lowest. And with all things, help menu. There you go, maximum diamond for the maximum standard deviation. So I very much encourage you to use the help key where you can, and the help is quite voluminous, as you can see. A lot had gone into that. So at this point, of course, I really don't want to, delete the data that I've just pulled off. So let me go and restore that. So the surface display the average edited depth, the shallow and the deep surface. Remember I mentioned there's the 3 surfaces. So that's that hole underneath the building, shows up very well on the deep surface. So you can look for high flow flyers and low flyers. Primarily, we're in safety of navigation. We're just looking for hazards to navigation, so we're mainly interested in what are the high flyers. But I can always go back through and say, well, show me the unedited surface, which is what I've just done. So now I can see that those points are back. So let's go back in there. The points that were manually invalidated, right, there they are. I want to restore those manually invalidated points. Now I'm showing all the points, and they're all back. That's how you can restore your data. What did I manually invalidate? All right. So, and I had this one down here, apparently. So there we go. Now, this is where you're actually going to save your edits back to your files. You know, the premise of PFM was not that you're deleting data or that you're creating new versions of files. That gets you into a file management nightmare. The idea is that you're just setting flags, the valid or invalid flags in your files. That way you can always go back and recover them. You're not deleting it, you're not removing information from the record, you're just setting various flags. So it can be undone. You can pull this stuff back apart. If it's all said and done, go back. It's like, well, what were my edits? And have a look at these things. Even back to your original files. So it's once you know, all that happens in the PFM structure. You're not actually going back to your files to change anything in them until you unload your edits. Now you're going back to your master files and you're changing some of the flags in your file structure. Say, all right, I don't want to say this is an invalid point, this is a reclassified point, etc., etc. A lot of times, if you have like a big area that's like kilometers after kilometers after kilometers, maybe you're working on it for a while, want a bathroom break, you know, unload the edits for the displayed area and walk on off. If you have a small PFM like this one, you might say, oh, you seem tired. Like, unload everything, I'm done with this, and go on about your merry day. And of course, so there's only 9 edited points, and I, you know, pull them all back out again. So everything is, once again, good to go back to its original state. Now, let's say I wanted to add a target. Let's add one. Let's say we want this to be a target. We can put a description. We can assign a screenshot. We can put images. How would you like to tag it? And it's going to ask, well, where are we saving this? So we're going to save it to a BFD, binary feature data file. It's in the same directory as our PFM in all of our data. It goes into the same spot, so it's all together. So yes, that's what I'll call it. Keep it as the same PFM number. And so now, oops, I should have that target. If I want information on it, there we go. That was our target. That's what we called it. And we have it in our BFD file. Now, what are we going to use the BFD file? We're going to use that for creating our enhanced bag surface. Bag stands for backing attributed grid, or big something something grid, however you want to say it. So, but now we've got that saved. So let's turn off the minimum maximum surface, and now we have a circle where our target file is. Now, I know you guys are interested in the automated target detection software. That's one of the interesting little tools in here, and we'll run that now. All right, let's do it now. So quit out of looking at the PFM, and then as my phone goes on, sorry. PFM feature. Read carefully, your help, quite extensive. This assumes that the PFM has been very well cleaned. Because of the target detection algorithm, if you've got flyers in your data, it's going to pick them up and it's going to mark them as targets. So some folks use this to quick sweep their editing procedure and go look for and verify that their targets are actually there and it's not just noise. Let's not do Liberty Ships one. Nope. So that'll be my PFM. It will add all features to that binary feature data, that same one that we'd already used. If we want to have an exclusionary, we can do that as well. IHO order 1 or special order, are we selecting features above 0? In this case, we are, just because we happen to know this is all land shots on this last data, so no problem. If we, it was this WGS 84, is it a local datum? We could always go get a rough ellipsoid offset from EGM08 to add on to that. Some more switches and options. There's the summation of what we're going to do. Run it. It's like 1 square kilometer, so it should be relatively easy. All right, there we go. So now if I go back to PFM view and open this one back up again, see all the red all the red dots? That's everything that's been flagged as a feature. Feature information created with PFM feature IHO order 1. And of course, because I told it to go look for features above 0, it happily went and did so. If I was doing this in an aquatic environment, I'd be like, no, anything above sea level or above 0, I'm really not interested in, provided I had my data shifted to the correct datum. So that's a quick way of getting your targets and being able to look and understand them. Now, I want to edit one, just edit a feature. Blam, there I go. What do I want to add in? What new classification do I want to put with it? And so those are all the features that it added. Well, let's say I want to add a feature. Sure, we know it's not a shipwreck, but we can, what we'd like to call that. It's a lighted beacon tower because I wish it to be. All right, so having said that, it should put it, and it did on the highest point. Now, in the event that it had not put it up on the highest point, I could move it. All right. Let's extend this a little bit so I see what I want. All right, we want to move it. I want it to be on that point, and it will gladly shift the reference point. Of course, I want it to be on this one. No worries. So those are now all of our features. So we've cleaned our surface, we've selected our features that we want to go through here. Let's extract to what would we like this thing to be? How do we want our data to be output again. Alright. All the points, the minimum surface, the maximum surface. We want to miss a point. How would we like this to be exported? No, I want to ASCII. What would I like this back to be back out as? Remember, with the LAS file, you don't extract the LAS data to another LAS file. There's really no point. You've saved it back to your LAS file. Let's say I wanted to make a shapefile out of all this. Okay, great. Nope, should have crashed. Oh, no, wrong one. Let's make it ASCII. Okay, so now we've had a chance to read that. Not the best idea when working with LAS data. So you could do it, but we'll back out of that one. All right, now creating a bag. All right, MinGW is essentially the bash shell for Unix for Windows. PFM bag is one of the ones that's not up in our tool bag because not a lot of people use it. But this is how you could create your bathymetric attributed grid. And it is very, very similar. The help menus, quite extensive for creating that. It'll let you select your feature file that you want to add into it. What is your bag going to be called? So, in the event that we wanted to see all the other command line programs that go along with the PFM suite, yes, this was all born on Unix platforms, so I hope you guys like to type. But there we go. Here are some. These are all the 3D executables and a lot of the smaller files run. Like, let's take PFM unload. This is the one that's called by the PFM unload button. But say there was something where you'd gone through and you had a doubt as to whether or not all of your edits had been unloaded. Well, you could unload, the name of my PFM and use the .u option as specified right here. Unload all data that's ever been modified. So it's going to run through the PFM file and look for any time it has ever had edited data that should have unloaded, and it's going to unload everything again. So it's just rewriting the same change to the file, resetting the same flag. I've used this before in various situations. Can be very, very useful. I'm not going to go into all of this stuff. Datum shift, if you're shifting your data, those are the kind of things that we would get into on in the 1 week course. So, but that's a brief overview of what you got and what can be done in here. Let's run PFM bag real quick. All right. Because we have the feature file, we can do this option. But be aware of what it's going to do with regards to creating that bag. What do I want to call the bag? Right now, I'm just running through with a lot of the default options. As an example, you guys can set this as you so desire. I come to our handy bag viewer. Well, what does it look like? There's the big ass grid, and there's our bag viewer. Now this one is it's weighted and modified with the feature data added into it. So, all right, that's part of what we've got, and I hope this at least gives you a little bit of an overview. Of course, there's a lot more digging, but this is a 1 week course where we're going to go through and dig through all of the little options and all the bits and pieces so you can understand fully what's going on. So I hope that gets you going. That's a rough workflow. Is going to be to follow this. You're going to create your area file if you don't have one already. You can also import like a shape file if you know what's your bounding rectangle for this entire thing. The area check, you can also use that to make off a minimum bounding rectangle or a polygon. You're going to load the data up in PFM load. You perform your edits, and the bulk of your work is going to be in PFM view. That's where you're doing your cleaning, you're doing your reclassification. It's not a classification tool per se. It's a reclassification tool. So your other programs for doing LAS and classifying your point data set, that's what you're going to use. This is if you see something that's wrong, okay, you can do some minor fixes. And you're going to create your feature file and let it go through, and then odds are you're going to go back to PFM view, load up your feature file, have a look at the features, make certain they are what you want them to be. They're where you want them to be. You're going to change labels, etc. Delete ones that you think were incorrectly picked or that you want to ignore. And then you're going to extract your data. If with LAS, you're just saving your changes and you've got it in your LAS file. If you're extracting to some other format to go into some map creation software, well, there you go. And then PFM geotip if you want to make images. All right, that's your quick run through on what this would take. That's about what I would have been able to run through in our webinar. Of course, we had some more questions, but there we go. All right, wish you guys good luck, and we'll try to set this up again. Let's grab hold of my worship. All right, guys. Thank you much. Appreciate it.